This is question 5 of the final exam. In the BJT circuit, this one, establish the operation mode of the transistor with beta 100. We know how to do that. Replace all the symbols with values and the transistor with its large signal model. Now let me identify the nodes. There are only two. One is the emitter down here. Of course, this is the base and this is a collector. The base is a binary node. We will not write an equation for that. We begin by using M&A to solve this circuit. Branch currents, this one, and this one will be controlling current IB. This is IB. This is IB. There is a controlling equation for this variable IB, and I'm going to write it CTL IB. Who is IB? IB is the current in an RV branch. Voltage of the origin VC minus voltage of the destination V minus 0.7 divided by 100K. And now we write those two KCL equations, one for node C, the collector. What is that equation? Currents going in. This one, VCC 15 volts minus VC over 5 kilos equals to the currents leaving that node, 100 IB and IB. That is 101 IB. Now one equation for node E, currents going in, IB and 100 IB, 101 IB, equals to the current leaving the node is only one, V divided by 500 ohms. Three equations, three unknowns, VC, V, and IB. These are the three equations, and the solutions are these ones. 21.8 microamps for the base currents. VC is 3.98 volts and VE 1.10 volts. Because the base current is positive, the transistor cannot be in cutoff. It has to be in either saturation or in its linear mode of operation. Which one? Well, let's find this voltage VC, compare that with 0.2, and then we shall know. VC is 3.98 minus 1.1. VC is 288 volts, which is greater than 0.2, so that signifies the transistor is in its linear mode of operation, and that answers the first part of the question. Linear mode of operation. The base current is positive and VC is greater than 0.2 volts. What about for part B? Well, let's see. Part B. Compute the percentage change in the collector quiescent current and in the collector emitter this voltage VCQ if beta changes from 100, which is right now, to 200. Oh, well, that means compute the whole thing with 200 and then compare the changes of the collector current and the changes in VC. Well, computing this for 200 is pretty easy because we still have in the calculator all these equations. We only need to change this for 200, right? Which is change this for 201 and this for 201 in the calculator. Anything else? No, that is all. And then solve in the calculator for the values again. But before doing that, still with beta 100, let me compute what was ICQ. The collector current in quiescent mode was 100 times beta. That is 100 times 21.8 micros. That was 2.18 milliamps. You know, I will have to compare those. This was VCQ. Well, let's solve that for 200. There are the three modified equations, 201 IB here and 201 IB there, and we are ready to ask for the solution again. Solve me that system, and here is the new current. Is the base is 11.86 microamps, VC is 3.08 volts, and VE is 119 volts. So the collector current, which is one of the values we want to compute, will be 200 times the beta current, and that is 2.37 milliamps. We got to compare that with the value we had before for that current, 218 milliamps. But let's determine VC. VCQ for beta 200, that is 308 minus 119, which is 189 volts. Also greater than 0.2. It continues to be in its linear mode, but that is not the point. Here we are to compare what is ICQ and what is VCQ with the values we obtained for beta equals 100. How do we compute the percentual change between any two parameters? We learned that in physics in first year. For any value x, we subtracted the new value minus the old one and compare that with the old one and multiply the whole thing by 100, and that was the percentual change of x. Well, we are to apply that to ICQ and to VCQ separately, so the percentual variation of ICQ is 237 minus 218, divide the 218, multiply by 100. Here I will compute VCEQ percentual variation will be the new 189 minus the old one, 288, divided by the old one, 288, times 100. So the percentual change in the collector's current is 8.7%, and for the VCQ is negative 34%. This means that when the transistor's beta changes 100%, the collector current will change only 8.7% and VCQ only 1/3. The feedback introduced by this emitter resistor and this connection is working effectively to limit the effect of changes in beta in the point of operation. This last part you did not have to answer with words. I just wanted to say that.